Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find area of the green shaded triangle? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. We want the area of the green triangle ABC. One side and two of its angles are marked, and those three facts pin down its size completely. Our whole plan is to turn them into a base and a matching height. The base segment BC is 8 units long. The angle at vertex A is 75 degrees, and the angle at vertex B is 60 degrees. Two angles known means the third one, at C, is already forced. The three interior angles of any triangle add to 180 degrees. Subtracting 75 and 60 leaves 45. So the angle at vertex C is 45 degrees. Notice 60 and 45 are both special angles, which is exactly what we will exploit. From the apex A, drop a straight perpendicular across onto the base segment BC and mark the point where it lands as H. Now draw the segment AH. It meets the base at a right angle, and it is exactly the height we need for the area formula. That altitude slices the green triangle into two smaller triangles that share the segment AH. The top piece is triangle ABH at the corner B, and the bottom piece is triangle AHC at the corner C. Because segment AH meets the base squarely, both little triangles have a right angle at H. That is the whole reason the altitude is worth drawing. Right triangles come with fixed angle ratios we can read off. Take the bottom piece first, triangle AHC. It has 45 degrees at C and 90 at H, so the third angle at A must also be 45. It is a 45, 45, 90 triangle. Our first insight is this. The 454590 piece transfers the altitude. Now the top piece, triangle ABH, it has 60 degrees at B and 90 at H, leaving 30 degrees on the right near A. So this is a 30, 60, 90 triangle. In every 30, 60, 90 triangle, the side opposite 30 is the short leg, and the side opposite 60 is the short leg times the square root of 3. Here, segment BH is the short leg, and segment AH is the long one, so their ratio is 1 to the square root of 3. Let us give the top base piece segment BH the name X. Choosing one unknown lets us write every other length in terms of it and reduce the whole problem to a single equation. Using the 1 to square root of 3 ratio in the top triangle, the height segment AH is X times the square root of 3. That is our height written purely in terms of X. Back in the bottom piece, we found the base leg segment CH equals the height segment AH. Since the height is X times the square root of 3, the bottom base piece segment CH is also X times the square root of 3. A second insight now finishes the structure. Two base pieces form one equation. Both terms on the left share a factor of X, so pull it out to get X times the quantity 1 plus the square root of 3 equal to 8. This isolates the bracket we will divide by next. Divide both sides by 1 plus the square root of 3, and X equals 8 over 1 plus the square root of 3. This is correct, but has a messy, irrational denominator, so we tidy it up. Multiply top and bottom by the square root of 3 minus 1. The bottom becomes 3 minus 1, which is 2, and the top becomes 8 times the square root of 3 minus 1. Having gives X equals 4 times the square root of 3 minus 1, about 2.93. Now, put that value of X back into the height. The height segment, AH, is X times the square root of 3. which is 4 times the square root of 3 times the quantity square root of 3 minus 1. Distribute the square root of 3 across the bracket. The square root of 3 times the square root of 3 is 3, giving 12. And the second term is 4 times the square root of 3, so the height is 12 minus 4 times the square root of 3, about 5.07. The area of any triangle is 1/2 its base times its perpendicular height. Here the base is segment BC and the height is the altitude AH. We worked so hard to find. Substitute the numbers in. The base segment BC is 8 and the height segment AH is 12 minus 4 times the square root of 3. The area is 1/2 times 8 times that height. Do the easy part first. 1/2 of 8 is 4. So the area is 4 times the quantity 12 minus 4 times the square root of 3. Distribute the 4. 4 times 12 is 48, and 4 times 4 times the square root of 3 is 16 times the square root of 3. So the area is 48 minus 16 times the square root of 3 in simplest surd form. As a sanity check, the square root of 3 is about 1.732. So the height is about 5.07 and the area is about 20.3. That is a believable size for a triangle standing on a base of 8. So the answer is 48 minus 16 square root of 3. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.